what we'll be teaching you today, data compression. So it's just you having your data and then compressing it. So, and by compression, I mean you are trying to like probably reduce the size. So when we are talking about compression, so I mean data compression, so we are just talking about you trying to like reduce the size of your file that you are working with. So, and the reason why we have to do this, because you might be wondering, so why does it really matter? I mean, why does it matter? So why does it matter? So you might ask yourself, I mean, you might ask me rather. So number one is because, I mean, just imagine it. Imagine this. I think I taught you the other time. I mean, so there was this document where I sent to the group when we first started, I mean, module one. So, you know, when we were talking about computer architecture and when we were talking about computer hardware, softwares, and things like that. You know, I told you that the majority of the computer that we have, they are limited in their capacity, in their, I mean, storage, in their memory and things like that. So you won't, I mean, have an unlimited computer. Just imagine it. My computer has, I mean, a specification that, okay, this is the memory and this, I mean, this is the RAM, this is the ROM. So I don't have like, I mean, an infinite RAM. I don't have like an unlimited ROM as well. So it is always limited. So because, I mean, we don't have an unlimited storage or RAM or unlimited address, so that means we need to find a way to actually probably manage the space that we have on our computer. So whether it is your memory, I mean, you need a way and efficiency to actually probably manage the space that you actually have on the computer. And so that is why, I mean, we need to like teach you how to actually do that. So that's why we're actually taking this course, data compression. So, because, I mean, our computers are unlimited. I mean, they are, I said they're unlimited. So they are limited in their storage capacity. So that's why we need to teach you. And the the second reason why we have to teach you, I mean, data compression is because, I mean, the data that we generate in bioinformatics are usually large and humongous. So we deal with large amount of data sets. I mean, we are talking of probably megabytes, gigabytes of data. And if you are not very careful, I mean, the data that you generate, all the data that you are being, I mean, you are generating might actually probably take up your computer space, which by the way, you know it is limited. So can actually probably just swamp everything up, I mean, pretty quickly. So we don't, because, I mean, we deal with a lot of data sets in bioinformatics and we don't have, I mean, an unlimited storage devices. So that means we need to find a way, an efficiency to actually manage the limited available space that we have on our computers. And the third reason why we have to probably teach you, I mean, data compression is because, just think about it. Majority of the bioinformatics software is that we work. It starts probably they can't probably process large data sets, but if the data set, if the size of the data set is actually very small, so they tends to do, I mean, they tends to kind of run very quickly, so they don't waste time. So I mean, if you should probably pass any small data set, so probably any bioinformatics source is going to like run it very quickly. So that means, I mean, if you can find an efficient way to reduce the size of your data set, so most likely any analysis that you are doing is going to be done very quickly. Because for bioinformaticians, I think for everyone, so I mean, there are three things that matters for bioinformaticians. Number one, you are particular about speed. I mean, you don't want to probably sit doing an analysis for probably a day, whereas, I mean, you have done it probably in 6 hours. So, I mean, we are particular about speed. I mean, time. Time is actually very, very, I mean, special to us. And also, we are particular about accuracy as well. So, we want things that will, so it starts probably to just run fastly. I mean, we also want things that will run, I mean, efficient, I mean, accurately. So, you don't want mistakes when you are trying to probably get this thing done very quickly. So, I mean, that is the third reason why probably we want to teach you this data compression, because the bioinformatics tools that will be dealing with, so they tend to work very fast and very quickly on small data sets. And uh, the third reason why, the fourth reason why we have to teach with this is so because by the time we start, sometimes we need to be fetching genomes from the database. So, the next topic of that is going to be databases when we are going to probably introduce to the common database that we have. But just think about it. If you need to probably download something from probably NCBI or any other database that we have, so if you are downloading a large data set, so it's going to download slowly compared to a small data set. So, and if you're also uploading the same way, if you're uploading from the computer, so probably a remote repository or things like that. Also, the size matters. So the larger the size of the data set you are trying to like upload and download, so the slower it tends to become. And this is why we need to like teach you data compression. So all these, large data sets, is there a way you can probably find reduce the size, compress them, so that by the time you are downloading and you are uploading, so they will download very fast. Like I said, time and accuracy is very important to bioinformaticians. So I think by the time we start bioinformatics proper, you guys will actually appreciate what I'm trying to talk about, because by the time you start fetching genome from any databases, or you are trying to like upload on databases, you actually see how painful it can be when you are downloading from probably remote repository database. So it's going to like take time. It's just similar to probably trying to like download your movies. The larger the size of the movie you are downloading, the slower it takes for the downloading to actually occur. So that's actually what's actually going on. And that is why we need to like, because time matters to us as well like accuracy. So that's why we need to teach you how you can actually compress your file. This large data set that we know that we cannot escape in bioinformatics. Is there a way we can still reduce, the size a little bit further, so that, our daily analysis is going to run smoothly. So I think with these 4 points, I'm able to convince you why this topic is actually very important to us and why we need to take it seriously. So everything they are teaching you, there are things that you come to appreciate later on. So, and then now we have to like start to the data compression. So what are the tools that we'll be using for this compression, data compression, data decompression, and things like that? So, the popular tools, and just let me tell you that, this compression that we are talking about, and all of these today majorly work on text file. The ones that you can probably open with your legs, your nano editor, or anything. So I'm not talking about the binary files, probably the ones that you generate from your Google Docs or PDF. I'm talking about text files. So the one you can use, open with your text editor. So, and one way to actually compress is to use a zip file. These are the tools that you can use to probably compress your file. These are the tools. So that you use zip files, and these are actual commands on your UNIX. If you actually probably just type it zip, you have zip, you can see. If you have bzip too, we have it. If you xz, there is xz. And whatever you want, so if it is gzip, you also have gzip. So all of these tools, so by default, you should find them on your terminal. Your terminal. So, and these are the tools that we'll be using to do our data compression. Like I said, these compression tools all work on text files only, not binary file. And the text file includes anything probably with .txt, .tsl, .csv, .fasta, .fastq, .faa, .fna, .ffn, and others. So any text file you can actually probably integrate out. So these are the tools that you can probably use to compress. So just to tell you that these are small letter, so let me just fix it. So these are small letter, not capital letter, so that by the time you are, so these are the tools that you'll be using. Yeah, I think we can go on. And like I said, I think I already said this earlier, that for bioinformaticians, speed, efficiency matters a lot, as well as compatibility, adoption, and support. So as you will find out later on, that despite the fact that we have a lot of tools that you can use to compress your file, we also notice that it's not all of them that have been fully adopted by bioinformaticians, I mean the bioinformatician community. So in fact, as we find out later, that the bioinformaticians tend to like prefer gzip. I don't know why they prefer it. So the most widely adopted of all of these tools is gzip. So that is why you will actually see that majority of the tools, I mean, of probably the files that you'll be seeing, they will have .gz extension. So by the time you see, that's because, I mean, these tools, I mean, this particular gzip has just been adopted by informaticians. That, okay, this is what we want to go with. But it's not probably you won't find the other also. You won't find the others. But the gzip tend to be common than the other. So, I mean, gzip is more preferred. So, I mean, by informaticians than the other tools. And another reason why it is actually probably preferred is because the majority of the tools that was probably created by bioinformaticians, all these tools that will be run, so they've been made to probably work well with anything that is compressed by gzip. So they've been made, I mean, they've been actually optimized to work well with any gzip file. So, I mean, so this is actually what makes them so popular. So, yeah. And I mean, I don't want to spend a lot of time on this, but this is just to tell you that, okay, these are the tools that we have, like I said, these are the tools. And by the time you compress any tool, any file using gzip, so what you have is .gz, and the relative compression is medium. As you can see, so despite the fact that xset has highest compression, I mean, ability, so it's able to like compress a file very well. It's not widely adopted by the bioinformatician community. And the reason why is because of what? Look at the speed. The speed is very slow compared to what? To gzip is the slowest. So because it is actually slow, so there's always this inverse, I mean, a trade-off between, I mean, compression and also speed. So if you see a tool that is probably very good at compressing, so most likely the speed is going to be, I mean, small. So there is this inverse relationship between speed and also compression. So that means that will always be a trade-off. So if you should probably prefer one, it's going to like affect the other. So that's probably you want to like probably prioritize, I mean, compression. So that means speed is going to be sacrificed. And if it is speed that you want to what, you want to prioritize, what the compression is going to be what affected. So you'll have to like probably sacrifice, I mean, compression or I mean accuracy. So that's actually what is just happening. So, but out of all of this, I mean, the bioinformatician just say, well, I think gcp is even much more preferred because at least the rate of compression is medium, the speed is fast, and but so that is why it is actually very common in bioinformatics. And look at bzip2. So bzip2 actually is, I mean, does better and performs better in terms of compression with what? With in terms of compression than gzip, but it is much more slower and it is a little bit, I mean, it's still very popular. I mean, you will actually come across basic file a lot. You will come across it, but it's not as common as basic files. So this is still the most common, I mean, compression tools that you actually come about, gzip. So, and you can see xed as well, and you can see zip. So zip is not really, it's common as well, but not as common as probably all of the stable by informaticians. So this one is just probably so regular people that are not probably really interested in bioinformatics. You know, probably all this ACA, all this stuff. So I mean, they use zip. So and then, like I said, you know, when I was at the beginning, I showed you that all of these things can be compressed using all of this. All right. But I mean, these are not the only text file that we generate in bioinformatics. These are not the only text file. So when it gets to probably alignment, sequence alignment, and parent calling, So do we actually come to learn about the tool called SAM2 and the tool called VCF2? So, and these particular tools, I mean, this SAM2, so these are the tools that anything that probably wants to do with alignment, mapping, and if you want to probably align your reads to your reference. So, I mean, you'll be using SAM2. And if you want to call a variant, I mean, where do we have notations in your, I mean, in your sequence? When do we have notations? So this one you'll be using VCF2. So you will see that by the time we start teaching you all of these things when we get to module 2, when we are teaching you about sequence alignment, so and variant calling, you will see that the kind of file that we generate something we call BAM files, which is, BAM and SAM file rather. So this should be SAM file. So sorry, so this should be SAM. So this should be SAM file. So we'll generate files like SAM file, and we'll also generate file like VCL file. These files, they are even much more larger than FASTQ. They are much more larger than FASTQ because they contain all the information that FASTQ contains, especially SAM file. It contains all the information that you will find in FASTQ. And it also contains some extra information as well. And VCF2 also contains a lot of information. So these are even much more larger than FASTQ. Just think about FASTQ. Whenever you hear anything about FASTQ, you're always thinking about, this is a very large data set. But this particular data set even has like, FASTQ file even have like, OGA, that like superior, and VCL file and SAM file, they are extremely large files. They are very, very large. And then, so you won't be compressing them with SAM and with probably either of these two. You'll be compressing them with gzip, bzip, xz or zip. So they have their own way of compressing. So I mean, they've defined, these tools, they've been able to like come up with a very good algorithm that is actually probably specific for handling SAM file and VCL file. And by the time we get to these two, we can actually see how we can also compress SAM files and also VCL file using SAM to SAM VCF2. So although I won't be teaching you this thing now, but I can promise you that it's a tool that you will actually come across in future lessons. So don't just, when we get there, just remember, I will probably be the one taking the course. Then I will bring your attention back to this on how we can actually probably do all of these things. So before I actually start with the practical aspect of things, you might be wondering, how does this compression even start? How does it really work? So how is it even possible to compress a file? How is it possible to compress a file? So those are the questions that you might actually ask yourself. Well, in order to answer that, I just want to like probably bring your attention to, although this is not supposed to be a computer class, but I just wanted to probably understand what is actually going on under the hood. So, if you can still remember your computer, I'm not sure whether you guys did any computer science course in 100 level or somewhere, your undergrad, or probably in your primary, no, in secondary school. So you might have probably come across something like bits and bytes. So bits is just binary digits. So that's actually where they got the name from. It's just 0 and 1. We've been telling you that the computer only understands 0 and 1. 0 means for off, and 1 is on. So because it's actually all this light stuff that actually controls, electrical signals that control how the computer behaves and things like that. So your byte is just the binary digits. It's just 0 or 1 off. And then when you now have 8, so byte is just 8 bits. I said bits. Bits could either be 0 or 1. 0 or 1. So by the time you now have probably so just look at this box: 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 different. So in a byte, you will see 8 bits. So, and these are the 8. Just look at all of those boxes. Just look at, okay, byte is just, so just regard a bit as a box. So when you now have collection of boxes, 8 different boxes together. So that is when you have a byte, right? So if you now remember your combinations and permutations, So if you remember your combination and permutation, so there are two different ways because you can either have 0 and 1 in this particular box. You can also have like 0 and 1 in this particular box. So that means 2, 2, 2, 2. So that means 2 raised power 8. So that means you can actually form 256 different characters using like an 8-bit architecture. I mean, 8-bit or 1 byte architecture. So if I say 8 bits, I mean 1 byte. So because the idea of, what actually led us to probably all these 8 bits or 1 byte architecture is just, look at your keyboard. We have a lot of characters. We have multiplication, we have alphabet, we have numerics, we have special characters, we have all of those things. So we need a way to be able to like represent them using 1 and 0. So that's actually what now led to all of these 8 bytes and things like that. So each of these, as I said, like because two stuff can be here, so there are two different ways to actually probably put something into this place. Two different ways to put something into this. So at the end of the day, by the time you do your combination and stuff, so you should have like 2 raised power 8 different ways. Different Z combinations, right? So 250, 2 raised power 8 different combinations. So that means those combinations, so that means we can actually form like 256 different characters that are very unique. So that means probably, let's say probably one can be 0000000. 2 can be 0000001. 3 can be 0000111. Things like that. So, but each unique, each byte that you form must be unique to a particular character. So that's actually what it's just a way for us to be able to like represent all these our characters that we can see on your keyboard or on your phone. All these characters, either alphabet, either multiplication, either because we know that computer only understand 1 and 0. So that's actually what's led up to all of these things. So that's what we have all of this. So that means if you now have like a one character, so that means one character, let's say probably A or B. So that means they will have what? One character will have what is equals to what? 1 byte, which is equals to what? 8 bits. I'll repeat myself. One character, just take any random character that you know, probably 1. I take 1. So that one character is equals to 1 byte, which is equals to what? 8 bits. Because 1 byte equals to 8 bits. So that's actually what is actually happening here. So you will so understand what I'm trying to like tell you. So because okay, let's just even probably start. So let me create a folder, make directory. Please, can you see my screen?
Yes.
Okay, cd into 4. So let's say probably I want to, I told you that one character is going to be. So let's see what will happen. Let me just echo Habib. And then name.cst. So let me lslh just to see. What do you see? So this one is talking about size, if you can remember how everything. So this one is saying we have like 6 characters, which is what? 6 bytes. And read, because if you cut what is in name.cst, you can see 1, 2, 3, 4, 5. It's supposed to be 5. But how come it is 6? And that is because there is an extra, so at the end of this thing, so there is an extra character called this. And this one has also been added. So every line we always have this. So that's why this one is 6 and not 5. But this one you just say, okay, we have 6. So this one is 6 bytes, which is equivalent to what? 6 characters, including this N. So all of these files that we are generating, all of this text file. So one character stands for what? 1 byte. And how the computer probably represents its memory is what? 8 bits. So that is actually what this one. If you see that if I should probably increase this to Habib, Ade. So can somebody probably anticipate what the size of this file is going to be before I run it? Can somebody tell me what the size of this is going to be before I run this code? Is it going to be 3 megabytes?
9.
Now, 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's run it. We have 9. So 1, 2, 3, 4, 5, 6, 7, 8. But because we have what? This one will always be added at the end of every line. Although you can't see it, but what is actually there is this. At the end of every line, you always have this. In fact, whenever you run WC minus L of any file, it's always counting. It is always counting this. Sorry, it's always counting this. And not so. This is what it's actually using as a signal, as a prompt for counting the number of lines. Although you might not, but this is what WCL uses to count the number of lines. So just look for, although you might not see it, it is actually invisible, but the computer can actually see that, okay, at the end of every line, so I'm going to put this thing. So that is actually what it's actually asking me. So that's why we have like main characters here. So that means if you should have like a faster file and you now have, let's say probably you have 1000 1000 bytes at the 1000 bytes. So that means you have 1000 different characters. So that's actually what that one is telling you, because we know that character means what? Our character is equivalent to what? 1 byte. And within a byte, we have what? We have 8 bits. Is anybody asking question?
Yeah, Victor, you can go ahead.
All right. So, quick question. So, if we have, let's say, we have Abib on the first line, and then we have Ade on the second line, like how would that infer on the size of the text file?
Yeah, so it's going to be, so that means we will have like probably here now where we have, what do we have? We have nine. So that means we are going to have something like probably 10. But let's try it. I will just probably do this. So cat name. I want to do this without cat name. How can I put escape? Okay, let me just do it manually. Nano name dot csc. So what will happen is this. So I'm anticipating that we'll have like 10, but let's see. So ls minus lh, you can see we have 10. So because we now have like two different, we have two lines. So this one is, so it's going to count this 1, 2, 3, 4, 5. So because this one will always have like this invisible character, I mean forward slash and what and n. Also here, so because this first side is going to be 6 characters: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Another invisible stuff that we can see. So that's why it is 10. So we have 10. I'm not sure whether you understand. Who asked the question? Please, do you understand?
Yes, I understand.
Okay. Yeah, I think we can go. Yeah. Okay. So this one was just to like probably tell you some history that, I mean, when the computer was first created, actually. So the first one that was created was actually a 7-bit architecture. And if you do your math, so that means we will have like 2 raised to power what? 7 different characters that can be formed from that. So we have 128 characters. And this particular 7-bit architecture was only catering to what? So English letters, numbers, basic punctuation control, characters like new lines. But probably it was not as we as the computer as this computer scientists kept generating more characters, so they needed a way to actually assign like a different what different bytes to this particular character. So that's why they now came up with what 8 bits, and with 8 bits you could form what you could form 250 different combinations and then assign that to different 256 characters. And then so with these 8 bits, so they were able to like add more characters like plus or minus, asterisk, this particular symbol, and what and division. So more letters. You know, there are some countries in the West that have this particular symbols. So they were able to add more characters, more symbols to what to the computer. So box drawing character for GI. So but this 8-bit architecture was only catering to what? So what to the Westerners. So it was not really probably catering to people from Asia, like all these Japanese that probably don't even have any characters that resemble, any English, alphabet. So that's why they now kept. So the latest phones are now Unicode. So with Unicode, they could. So this one can, with Unicode, you can actually generate billions of characters. So that one, we cannot even exhaust the number of unique stuff that we can assign. So the all these current computers that you are using, so the use of this Unicode stuff. In fact, we can actually see it in Unix. If you press locale, we can see probably the kind of architecture that we have. We can see that our own thing is actually using what UTF. It's using UTF Unicode 8. So and with this Unicode, you can probably generate like billions of different characters. And I don't think we've even probably exhausted those characters yet, because I don't think we have up to like billions of characters in the world. So probably the highest we can is probably millions. So with Unicode, we have like an exhaustive, something we cannot really exhaust. Different things that you cannot really exhaust. So that's how this also tell you some of these things. And then okay, so I think this is now the point where we start, really practical stuff. So yeah, I think I have 1 hour, so I should be able to like finish. So I have 14 slides, so I'm slide number 9. So the first tool that we'll be talking about, I told you that we have 4 different tools that you can use to compress your text file. Although we also have, let's say probably we have like 6 that I really know about, that are really common. So we won't be teaching you some tools and PCF tools, but the 4 tools, zip, gzip, bzip2, and also exit. So we'll be teaching you that in today's class. So the very first one that we're going to like talk about is the zip2. And the first thing you have to like know about this particular tool is that you can use it to compress a single file or multiple files and or folders before and of folders. But the way it works is that it's first going to like probably by the time probably you are trying to like probably zip multiple more than one file and or folder at the same time. So what is going to happen is it's going to first compress all of them before bundling. So it does 2 things. Zip2 does 2 things. It does compression. It also does bundling. What I mean by bundle is it's just you trying to like bundle. I'm not sure whether I have. So something like this when you are trying to like bundle things together. So the English bundle. So it does 2 things. It compresses and it also bundles. But there is order in how it does it. The first thing it's going to do is it's going to first compress. Let's say I'm talking about if you are probably trying to like zip more than one file and or folder at the same time. So what it's going to do is it's going to first compress all of them before bundling them together. I'm not sure whether you understand. So and this is the general syntax. So zip, the options here, option is the same thing as flag, and probably what you want to call. Let's probably these are the files that you want to zip and you want to compress using zip. And then you still want to bond. So you have to first list them out. And by the time you are done, so this is what you want to call them. So after probably doing the compression and the bonding, so this is what I want to call them. I want to call them output.zip. I mean, although this extension is not really needed, but we always tell you that always add extension. The reason why you have to add extension is it's going to make your life easier. Number one, for organization. Number two, so let's say you want to exploit the use of what? Wildcards that Richard Wright taught you and all this meta character stuff. You want to exploit them. And probably you want to start writing your code. You can say, okay, for loop, and you can write a loop that, okay, that will match a particular pattern. So by the time you put all of these things, extension, it's going to make your life very easy in terms of organization, readability, and also in terms of being able to work with this file. Because you don't have to probably enter into them before you can probably determine that this is a zip file, this is a text file, this is a CSV file, this is a BAM file, this is a SAM file. So that's why you need to put all of those stack. You might be thinking, well, it's not necessary, it's not necessary. They are necessary. It's going to make your life very easy. I will keep repeating it. Always add extension. Although all of them are all text files, whenever I'm writing a script, I always put .sh just to say that this is a bash script. If it is a Python, I'll put .py just to differentiate that this is not a bash script, so this is a Python script. So I don't need to probably start pressing cards or less and start saying the content before I can say, is this a Python code? Okay. So it's going to make your life very easy. So please always just inculcate the habit of putting extension. So the reason why this one is there, although it's optional, is just for to make our life very easier. So that's why it is there. So this is just the general syntax. So if you are compressing directory, so you have to put this option -r, and then let's probably the file you want to compress like a project. What is going to happen is zip is going to enter into this project, compress all of those individual files that are within this project, then bundle them together, and then name it this. So we're going to see a sample. And then if you are combining both files and things simultaneously, you still have to add your -r option. Otherwise, it's not going to work. But with files, let's probably just file that you are dealing with. You don't need the -r option. So let's see some example. So please, do you understand this up to this point before I even start?
Yes, sir.
Just, I think it's only Victor that is getting this. So please, are we getting it, others? Others, so please.
Yes, sir.
Okay. Thank you very much. I think we can continue. Yes. So let's say probably I have file on this particular file. And then let me create another one. Touch. I'll just put AAA TTT a sequence. Sequence.txt. So ls. All this one please. Oh, I made a mistake. So this should be echo. Nobody told you. So let's name.txt. Okay, we have that one. Let's sequence.txt. So we have our sequence. So how can we use zip? I told you zip does two things: compression and bundling. But so there's another, so how it does it. So compression is going to come first before bundling. So let's see what will happen. So the code is what? Zip. So let me just say, let's go we have first. Zip, if you remember, but because what we want to combine, want to compress and combine, they are what? They have test files. So just a zip, so that you do this. So the first thing that I have to come after this is what you want to name it at. After everything. So what do you want to name the results of the compression and bonding? What do you want to name? So I will just probably put what can we even name it? Probably combined, I don't know, combined dot zip, right? And then your file, right? Although you could do this, but I say well, you can actually probably do all of this thing without, but so don't let me complete. Let's shall go with this. Zip combine. So this is what we want to what? This all of from years to year. So this is what we want to what? We want to compress, right? And this is what we want to save it as. So by the time you run it, you can see adding name dot store adding this. So let's now ls. So what can we see? We can see that what combine dot zip has been formed and also name. So it still retain a question. Okay, this is the question.
Okay, sir. So quick question. Does the zip command need to be installed or something?
No, it doesn't have to be. If we are using, I'm not sure about git bash. Like I always say, git bash is not really like a full-fledged terminal. It's just a terminal that was like a mini terminal that was just developed so for you to interact with Git. So, but if you are on Ubuntu, so I will still encourage you, despite the fact if you have Git bash, that is not the end. So just find a means, no matter what, to download Ubuntu so that you won't get frustrated. If you're on Ubuntu machine, I think you should have zip file. And all of these tools I'm talking about, you guys should.
Because I tried using zip and then it was saying the command zip not found, but I need to install it using sudo apt.
Yeah, so that means probably you can install it using the sudo apt.
Okay.
So probably I don't know, probably in the past, I shall know that when I opened my computer, so I found it. So probably it came with I'm using Mac OS, so I'm not even using Ubuntu. So, but they're kind of like similar. So, and you can see when you run this code, so you have this output. You can see that what our zip file has been created, and also what our initial files they've been retained. So it did probably delete them. So by the time we start looking at saying, gzip and bzip, and I say we see that those ones they will compress and then delete the original files. So this is how you can actually do this. So let's now see. So let me create a folder, make directory folder. Let me just call it folder. So I told you that it's also possible to actually probably compress a folder. So let me just probably copy name.txt to folder and then sequence.txt also. To folder. Oh, sorry. I'm always getting ahead of myself. So we can ls folder just to see. So we have it. So let's see how we can probably compress a folder. Zip. So remember, okay, before I'm even doing this, we should be looking at the size because that is the purpose of this class. Initially, look at the size of all of this thing of name.txt. Can you see the size? So the original file, look at your size, 10 bytes, 7 bytes. But by the time we now compress it, we have 335. You can see this is not a good compression. Abi now? Yes, it's not a good compression. The reason why is because although it's compressed, so whenever you are compressing, it's also going to like add additional comments, probably timestamp and additional like metadata that you might not be able to like see. So it's adding some other stuff. Okay, so this is the date. I mean that this compression was done. This is the time. These are the files and things like that. It's adding. So that's why we now have more characters here. But as we will see later, I'm not sure whether you guys are you know a little bit of probably calculus or so there's something we call limits. So for your stuff to actually make sense, I mean, you need a limit. So, I mean, for all these compression tools that we are seeing, for them to work efficiently, you need to have like, there is a minimum number of characters that you have to have. So, in fact, if you are probably compressing a smaller, if you are compressing a smaller file, your compression will be shooting up. So it's not going to compress efficiently. It's always going to generate more characters than the original stuff that the original starting the original file that you are compressing. So there is always a limit. I mean, an optimal limit for some for these two to actually work optimally. So they have a limit when they work optimally. So you cannot just say, okay, I want to start compressing any file. So they have to. There's a minimum number of what characters or size that a file has to reach before it can actually probably compress meaningfully. I'm not sure whether you understand what I'm trying to like talk about. So there is always a limit. So and there's a limit to what I'm so when these tools actually perform very well. So as let me before I even move on, let's try and probably even generate something. So I will just probably uh let's write a code. Okay, nano generate sequence. I just want to show you that there is a limit of what this thing can do. Nano generate sequence. So remember to always write this, your bin, root bin bash. And this I told you, I mean, it is specific to what you have, I mean, on your, I mean, I told you. So there are instances when that particular line is going to fail. So just want to write a code like for I in, I'm just say probably 1 to 200. Do echo $1. So I want to write a code that will take a particular sequence and then repeat it multiple times. So that's what this one is trying to do. So and then I want to save it. So probably file no $2. And when you are to put done, okay, I don't want to overwrite it. So I want to append. I want to be appending. Sorry. So Control X to yes this. So by the time you do that, although what we tell, I mean, let's just follow the normal. Although somehow, like on my own terminal, sometimes I don't actually need to like probably run this thing for my code to actually run. I mean, for me to be able to like run my bash script, but let's just follow the thing so that you won't get confused. So we've done that. So we've made it executable now. So now what we want to do is I want to generate a sequence. So I can say probably bash generate sequence. So my $1 is going to be whatever I want to name generate. Let me just say a t t t t no, a t t, and then I want to call it file1 by 1.txt. You know this is going to be $2. So your $1 is this, and this one is going to be repeated multiple times, right? So I think I should have it now. So if I now see ls by 1 dot, so you know I have that sequence. I've repeated it 200 times. So that's just the code I was trying to like. I was just trying to like repeat this, and I want to create another one that is probably GATC CCT. So just one random stuff. And if you less file 2, so we can see. So we have 200 of those things repeated. And the reason why is because, whenever you are doing anything repetitive, so that's when you use loop. You just reiterate. So, and after that, I just want to show you something that you need to have like a certain minimum number of characters before all of these things can run efficiently. So let me show you something. Okay, I think I want this to be a small character compared to this one. Okay, so ls minus lh. So look at our file 1. Oh, this one is 4,000 kilobytes. I said 4,000 kilobytes, 4 kilobytes. So that is like 4,000 bytes, right? And this one is 3.2 kilobytes. Let's now see when we zip whether we will achieve our stuff. I've just called this combine 2 dot txt. The first one that we have is combine dot zip. So combine 2 dot. So you want to compress file 1 dot txt. You also want to compress file 2 dot txt, right? So we've done that. So let's now ls lh whether our compression file is going to be low, much more lower than we can see. Look at the individual files, 5,000 kilobytes, 3.2 kilobytes. Now we now have still only down 83 kilobytes. Do you understand what I'm trying to? So that's what I was telling you about. There's a limit. You don't want to be compressing a file that is small already. So you need to have like a large file or something like a minimum stuff share before your compression can actually work efficiently. Am I making any sense?
Yes, sir.
This is just one person that is talking. Others, please, are you getting it?
Small, sir.
You said small.
Yes, I will rewatch it.
Okay, no wala. I am Akintayo. Just
Hello,
7
sir.
people.
I'm,
So,
I'm, I'm, I'm with you. I'm with you, sir.
okay, Joyce.
Yeah, I'm with you, sir.
But are you getting? I know you are with me, but are you getting it?
And somehow, but I still have to rewatch it. I
Okay,
didn't join the time.
all right. Please watch it. So that's what I'm just trying to like tell you. So that is how you do zip. So like I said, I just want to show you how, I was telling you about, okay, we want to like probably zip the directory. So you have to hide minus out. So let's say when we try to like probably zip the folder dots. Zip.
Sorry, sir. I have a brief question.
Okay, please go ahead.
Yeah, so I noticed that when you're doing the last zip command, that you use combine 2.txt. So I thought,
Okay. Yeah, sorry.
so I want to know if it's meant to be .txt or .zip.
So it's supposed to be dot zip. So yes, because it's supposed to be dot zip, so it was a typo. So yeah, let me delete that. Remove combine. Thank you, Gary. So I'm going to rerun this particular code. Put zip and then ls minus lh just to see. It's still the same thing that we'll get. 383, but just the name. So thank you very much. So all right, ls. So this is what we want to like folder. So let's see how we can actually, our folder is not anything, and you can confirm that using this. So inside this our folder, we have like 2 files, called name.cst, sequence.cst. So let's see whether, let's do it wrongly. I want to do it wrongly. So just say probably folder.zip, right? And then our folder. You did work. I think it worked. Yeah, it worked. LS minus LH. So LS minus LH, you can see we have 164. Initially it was 128. But let me put the minus R. Although I was not expecting it to work, but somehow it works. But probably your own stuff, it might not work. I don't know. LS minus LH. So this one is now 505. Somehow there is something. So I think without this minus R, it's just compressing the folder itself. But with this one, if we put minus R, it's going to combine the individual, it's going to like compress the individual files within that folder. So that's actually what it is. So with this one, it's just trying to like, okay, we'll combine what we have. I mean, compress what we compress the folder itself. But this one is now compressing, I mean, the individual files that we have in that folder before now bonding them together and giving us saving it as what folder.zip. So that's actually what is going on. We can see from here that without R, we have 505 bytes, and with R, we have 505 bytes, and without R, minus R, we have what? We have 164. So yeah, I think we've spent a lot of time on this. So, and if I actually want to combine, I mean, both the files and folders simultaneously, so this is the command that you run. So I think probably I will just leave this one for you to try out yourself. So just like we can compress a file, you know, I mean, some of these things you guys are even familiar with it on your, on your Windows. You know, I mean, the graphic user interface. You know, when you want to, there is a way you can actually compress a file and decompress. So basically, everything that we are doing using our graphic user interface is also what we are repeating here. Repeating everything. So if we want to decompress a file, like not just any file. See, if you compress a file using zip file, you cannot probably decompress it using another tool. You cannot say, okay, I want to decompress using bzip2. It's not going to work. But you want to decompress using gzip, it's not going to work. So if you use a particular tool to compress a file, you must also use that particular tool, to unzip it. Am I making any sense? So that is why extension is also needed sometimes. But now that we have something like this, we shall know that, okay, well, this thing is a zip file. So we can now use like unzip to do that. So let's see how we can. So with this zip file, I told you that when you zip a file, it's going to like compress the file and then bundle it. So, and then it's not going to delete your file. Like now that probably we've actually finished, so we already have repetition. So we can just probably delete some of these things. So let's probably I delete, in combine one and thing, I can delete all of these individual files. I can remove anything that end with TST. You can see I've deleted everything that ends with TST because I've compressed them and I've bundled them into some name.ts and sequence.ts are here. File 1 and file 2 are here. And the folder stuff are here. So I can even probably delete this folder. Should I delete it? Yeah, let's delete it and see what will happen. So you can say remove -r folder. We've deleted it. So let's see whether, we've deleted all of those things. Initially, so this was what we have, but we've deleted it. So by the time is it uncompressed or decompressed now? So the compressor, this thing. So we see that, and we should be able to like get all of this file that we deleted back. So let's try. So let's say unzip. Let's first unzip this. So ls. So we can see name.txt and sequence.txt. We have them back. So let's see the contents. Abib Ade. So that was the contents. So and sequence AAT. You can see we have that. Just to show you again, this is what we have. So let's now unzip the second one, which is combine this So, and then you will see that we have like our file 1.csc and file 2.csc. So if you ls now, you can see file 1.csc, file 2.csc. Is it making sense? And then unzip
Yes.
our folder.zip. So ls, you can see we have our folder back. And let's see what is inside our folder. You can see we have our stuff. Is it making sense? So that is actually how
Yes, it is.
compress using the zip. And you also, I don't know the right English. I'm not sure whether it is uncompress or decompress. Can somebody find out for me before I start saying it? You know, this thing is going to be posted on YouTube. I don't want to be trending. Don't compress. Compress.
Is it compressed?
It's decompress. Okay, thank you very much. So Chico, I'm not sure whether there is a way we can edit all of this stuff out. All right, so I think we need to go to the next command. So this is actually how you unzip. You can see you zip using this, you unzip. So the next one is tar. So the reason why I had to put tar is tar in a way is related to, in fact, to zip. So tar means tape archive. In fact, you know, before all this Wi-Fi age and all of this Intel stuff, before all of this GitHub, you know, I mean, GitHub is now, I mean, one way of probably sharing codes, sharing things. I mean, by the time you are probably write a code or you do something, just put it on your GitHub. People can always go there and download it. So, I mean, GitHub is now probably one way of probably shipping out softwares. Although that's not the only way. Some people use Docker. So it's a popular stuff that people use a lot in bioinformatics, but we won't be teaching you Docker. So by the time you grow in bioinformatics, you can learn it yourself. So Docker is also one way of probably shipping out code. Some other ways is all this Nextflow, or this pipeline stuff. So that is also one way of shipping out your code. GitHub, one way of shipping out your code. And all of these, what is it even called? I've forgotten. But so there are so many ways of shipping. I mean, latest way of shipping codes. I mean, those are just what I just told you about. But then the way people probably ship their code and things like that is using tape archive. So tape archive, just remember, like probably, so that's why I just put this box. Tape archive means you just bundling things. It's just a way for you to bundle file. So tape archive does not really, it cannot really, by default, it does not do compression. It's just for you to, just probably you have like, okay, you have a file and you have like a code that you've written. And I want to ship it out that, okay, I mean, this is the code I've written. So if you actually want to probably run this code, your file should look like this. You know, you are combining the two things, like a template that is compatible with your software that you've written. So you can actually bundle everything or any dependency, anything that is needed by your code to work. The other one I was trying to like tell you of probably shipping is through all of this Conda stuff. I mean, so Conda is a way to actually probably manage to download anything. The other one is sudo that Emeka told us about. So sudo is also a way for you to probably put any of your software stuff on probably sudo database. I don't know. So, but then the way people actually ship their code or things like that is probably through the archive. So they just bundle everything. Let's probably write a software. Everything, the file, like the configuration settings and everything that is necessary for that particular software to run successfully. They will bundle everything together. So that's why I just put this. Just look at this box. Just like you trying to like bundle things together and say, okay, this is the tool. I've generated the tool. These are all of the tools that you need for it to work successfully. You know, just like you buying a television. If you buy a television, you need remotes, you need code and everything for it to work successfully. So that's actually what is happening. Although it is television that you are buying, but you are getting some other things as well. So that's actually how tape archive works. So tape archive is kind of like similar to zip, but it does not do compression by default. So that's why I say strictly for bundling files and not folders by default. And this is the basic syntax. Ta. So you can see that this one is also like the same syntax with probably zip. I mean, zip also, you have to first specify what you want to like name what you are bundling together. And then, your file and folder, you have to like specify. So that's actually what's happening here. So let's see how we can tar ls. So, yeah. So we want to create a tar file now. So, and the syntax is what? Tar, tape archive. So now you need option. You need some options for it to actually, because if you don't specify those options, your tar is not going to be successful. So, and the two options I'm going to show you first are C, tar minus C. And this one is saying, okay, tape archive, create. So this C means create. So you want to create a tar file. F. So this one means create a tar file with the file name. So what do you want to name the file name? So we can just say probably combine dot tar. Remember, because it's a tar file, we are not putting zip, although it doesn't mind. But so that you don't confuse yourself, just put tar. So I'll be able to know this is a tar file. If you put txt, it's going to run, but you are confusing yourself. You are not confusing the computer. You are the one confusing yourself. The computer will still know that this is a tar file, whether or not you put dot star on. But if you don't want to confuse yourself, always put some tag that will make your life easy, and some extension rather that will make your life easy. And this is why we are putting dot tar. And then we want to probably tar. We want to combine. Let's probably sequence.txt and name.txt. So this is what you want to do. So by the time you do this, your tar is going to run, and then ls. So you can see we've generated our tar file. So I'm also going to do it again for the same thing for file1.txt and file2.txt. File1.txt, file2.txt. So this I'm going to name it combine. Okay, so it should come. This one should be combined to dot star, right? ls. We can see we have combined to dot star, right? So similar to, like I said, it is similar to what? To zip, but it does not. So the only difference between them is, okay, zip does both compression and bundling, right? While tar only does what? Bundling. It doesn't compress by default. Later on, I'm going to show you how you can actually probably compress using tar, but by default, it doesn't compress. So, and by the time you do this, so this is, by the time you run it, you can see that we have our what. So let's delete all these sequences that we bundle. I can delete everything using wildcard. So that is why we say you should always be putting extension. So let's say probably you didn't put extension, and you'll be deleting them one by one, 4 times. But now by the time you put extension, you will just use wildcard to match those extensions. So that's why extension is good. You get. So instead of probably first deleting file1.txt and then deleting file2.txt and then deleting sequence.txt, deleting name.txt, I can just, exploit the use of wildcard because all of them, they are both .txt. So I can just probably just use this one at once, and then we can see I've deleted them. So how can we now untar? So this one is not about compression. We want to untar now with tar. We don't want to untar. So how can we untar? So ls again, just to say how you can untar is. So this one is not going to, in the case of zip, you say unzip. You can't say untar here. So there's nothing like untar. So it's going to be tar. So when we were creating, we were using -cf, right? For now, it's going to be -xf. So this x means extract. you are just changing the C for what? You are changing the C to what? To X. So when we are creating, we're using tar create file. This one is tar extract file. And then the name of the file you want to untar. Let's first untar this combine.tar, right? And by the time you do that, what will happen? You can see you have your sequence txt and then .txt back. Because we just bundle them together. So we are not really losing any, so we are bundling together. So whatever you unbundle, whatever you bundle, you can unbundle to get. So, and then let's see. So we need to what? Extract the second one as well, which is combine two dots what dot star. And by the time you do that, you can see we now have what our file 1.tsc about that we bundled into what? Into combine.two type. Does it make sense? You can see in the way they are kind of like similar. The only difference is that okay, zip does not. I mean zip does both compression and bundling. Whiter only does bundling by default. So let's now see how you can. So okay, when I was doing it, I was already showing you the size. So you can see the size when we bundle. So the size is still when we you can see the individual. So inside combine two dot star, you can see you have 9.5K when we bundle them. It's not really doing any compression. So we expect the size to actually probably increase by the way. So we combine both files. So you can see the addition of this thing is supposed to be what 7.2, but you have like 9.5K. So it has added something. And for combine for inside combine dot star, we combine what is inside it should be this one and this one. There should be 17 bytes. But now we now have about 3,000. So that is Juju. But let's continue. Please go ahead.
All right, sir. So I have 3 questions. The first question is the tar command. Can we also use, like, is it similar to the cat command in terms of trying to concatenate?
Is it similar?
Yes, to the cat command in terms of trying to merge maybe 2 text files together.
Yeah, they are not similar. And I will tell you why, because if you are using cats to concatenate, so what you are getting is you are getting a concatenated file. So the individual file will still be retained, and then you will get another file that will now contain the content. So this one, we are just we are just combining the file itself, not the contents of the file. I'm not sure whether you understand.
Okay.
So one is combining the content, one is combining the file itself, not the contents. So cat is combining the content of 2 or more files.
Okay. Then my second question is can we, like, let's say for instance we compress A and B file together, and then we compress C and D file together. Can we now compress the compressed file of A and B and the compressed file of C and D together?
I think you will have to try that out yourself, but I think it's possible. Yeah, it's actually possible. You can compress the individual file and then start them.
No, like, the thing is, you have 4 files: file A, file B, file C, and file D. Get.
Okay.
So I use the maybe zip command or tab command, and then I compress file A and B. Get, and then it gives me a zip file already, and I
Okay.
compress file C and D. It gives me another zip file.
Okay.
Can I now compress both zip files into one zip file?
Yes.
Okay. All right. Then lastly, can I decompress a zip file into a folder?
A zip file into a folder.
Yes.
It's not
Um.
possible.
Okay.
So because since it is a file, it's still the format of that file is still going to be preserved. So you cannot, it's not going to probably now say, by the time you are decompressing it, unless probably you have a folder. In this, there's a way, if you actually zip files and folder together, by the time you unzip them, you will still get those file and folder separately as they were initially.
Okay. Like so. Like how it is in my head is that, let's say there's a folder here
Okay.
that has two text files. You get, and
Okay.
then I zipped the folder, or I even zipped like two text files into a .zip file. Yeah, so and then I'm trying to unzip or decompress it. Can I like redirect it to a folder so that the folder will now have the unzipped files? I know what I'm saying makes sense.
I think I understand it, but I've never tried that before. Although it's
Okay.
possible, all of those two, you can actually probably try it out yourself and then see what you get.
I think
But
you can check it as well, Victor. Although I think I've tried it a few times before, so I think you can redirect. I've forgotten the particular option. Like it's either you redirect to a destination folder that you already have, maybe the one you've created, or maybe the one you're about to create, or you use. I think there's a flag. Um, I think minus D or something like that. Like unzip the files and then where you want to redirect them to. So I think it's possible, but you can
yeah.
look it up.
All right. Okay. Thank you.
All right. Thank you very much. So yeah, I think we are done with this. So the other thing I want to show you with tar, I told you that by default, tar just bundle. It doesn't do compression, but there is actually a way you can actually compress using tar. So all you just have to do is remember this used to, this was the first, the code we ran initially, right? So I just want to show you before I run it. So this ls minus lh, so that we can compare the size. So I now want to rerun this again by compressing it. This was the first one that we ran. So if I add the x, I said a z option. So this one is saying, so this set option gone zip. I say gone gzip. So it's one of the tools that I will introduce you to later. So look at this. If you look at this option saying, okay, use gzip compression. So by the time you specify this minus z, you can see I said bundle and compress using gzip. It first bundle before compressing. So unlike so that's why I said other matters. In zip, it first compress before bundling. But here, by the time you specify set, it's going to bundle first before compressing. Please don't mistake the two together. So by the time you add this option, particular option Z, so that's what you need. And that's probably you don't want to use the gzip for the compression. You want to use probably bzip too. So you have to specify minus J option instead of this Z. And if it is probably excess compression that you want to use, you have to specify uh, capital letter J as the option, as instead of this Z that we have here. So you can use whatever compression that you want, but we are going to go with what minus Z because that is the most popular among mathematicians. So, and now let's see, by the time we combine it, so what we want to do is you can see that I've introduced before, it was just these options that we have. Now I've added another extra option, which is minus Z. Right? I've added it. which means, okay, bundle this file, name it combine.star, and then compress it using gzip tool. So that's actually what is going on here. So if I should do that, so there's something I want you to track the size. You know, the size of combine.star initially was what? 30K. Let's see whether there will be some reduction, I don't know, or we'll have to find out. So ls minus lh now. ls minus lh. So this one is now what? 300 and Abi. So there's no really, no.
So you did not remove it. You did not remove the first combined data.
You mean this? Yes, it was deliberate. I know I didn't remove it.
Oh,
So I just want to override. So that's why I was I asked for ls because this was the size initially without that z minus z option. So you can see it didn't really do much again because I told you. So there is a limit to what you have to have before successful computation can actually be achievable. So it was not really power, it was not able to like do a lot here. So okay, let me add this just to say. So this V is optional, it doesn't have to be there, but just trying to like tell you what is going on so that by the time this thing is done, it's just going to like probably give you a message, but it's still the same thing. I don't know why. So ls minus lh. So no much difference. So you can see. But this one is just saying, okay, combine this, just trying to like tell us, what is actually going on. So by the time you put this minus v, so others actually matters here. Initially when I ran this, it didn't give me any message. Well, and I had to like probably switch the order. So this one just say, okay, we'll create verbosely file using this, and then I'm going to do this, and then we have minus lh. So we can also do this for the
I
second.
think we have a question.
You said
I think
okay,
we have a question. Or can you take it later on? Or you won't take it now?
I can take it now.
Okay, please, you can go ahead.
Okay, thank you so much. I want to ask, when you use the ls minus lh before you added the z,
Okay,
the last line was sequence.txt, that is the last line.
this one.
But after we did that, we have two extra lines having the vz and the z.
Oh,
So I don't understand that.
I actually didn't suspect this. Sorry, I'm coming. So I think what was happening is because initially when I did this, I think the issue came because of the order. So in this particular options or the order, so when I was so initially this should be the correct syntax: create verbosely vz. So let me just delete so that I can show you. Control A, Control Q, ls. So this is what we have. So let me delete, remove vz, remove z. So if I should run this, you can see that I don't have them again. But if I should run this, let's probably I didn't get the order right. I should do this. I'm expecting that probably this one is going to create v, or I don't know. You can see set v. I think it was because I didn't specify the order very well. So it's actually probably this thing means different things. It means like by the time you specify this option like this, it means a different thing to tap. So that's why you have this. But this should be the correct. So this is actually the correct syntax. So normally I think it's just the first instance of where probably order actually matters in all these flags that we used to put. The other one that I'm very sure of is all this when we get to these SAM tools. So you have to get the order right. But this should be the correct syntax. So create verbosely file this, and then we'll have our desired results. So you can see, in fact, it even creates this zip file. So I think it's creating another one. So that I think probably this should not be the correct. So let me change this to Z. So I think this file has to be the one to come last, whatever you are doing. So yeah, I'm not sure whether I'm able to answer your question. So they were generated because I got the order wrong. So this Z and Z and ZV. So they were created because I got the order wrong. But this should be the correct order. This do I answer your question?
Yes. Can you use the LS minus LH again? Let's see.
Yeah, it's still going to be there, of course. So if I should delete them again, Z, they are gone. So if I now use the correct syntax, they won't be there. And then ls minus LH, they are no longer there. So and you can see my tar has now been reduced. You know, before, because I didn't get the order right, it was not really doing the compression. But because now that I've gotten the order, you can see from 330, we now have 170. So the compression was actually done successfully. So order really matters in this. So I shall know that whenever you are doing this F has to be the last thing to come. F. So has to be the last thing to come. But the other ones, I think probably order doesn't really matter in the other ones that precede. But let's test that just to be sure. Let's probably like put Z. Yeah, I think order does not. But that F has to be the one to come last. Yeah. So that's just take away from this. Do you understand?
Yes, thank you so much.
All right.
Very much.
What star is doing. So tar, if you actually want to compress, so you have to add. So that means I have to switch this. Create. I think it makes sense this way. Yeah. Okay. So the next thing, Tutuko, I'm not sure whether I should continue. It's already.
Just
I
have
think I should
4 minutes.
let me just finish this, how to extract, and then I don't think I have. It's just two slides. I think probably I can use probably 30 minutes next class to do that, or 15 minutes. So let me just probably do this and then we'll call it a day. Hmm? What do you say? Tochi.
Yeah.
Okay, I think this one we even got it. So because we've actually, so we didn't add our extension. So we need to add the extension here. It's also matter because we've compressed. So and because we are using gz compression, we have to like put gz just so that we are sure. I mean, it's just for our own good. Although the computer shall know that I mean we've done some compression, but so that I mean you don't run into any issue later on. So it's possible, advisable to actually add this particular extension. This is why we're adding the extension because we are what we are compressing with what with uh zip, I mean the gzip extension. I mean the gzip too rather. So you have to add it and then ls minus lh is going to be created. Although this and this, although they are still the same thing, they will be the same side, but just the name that is changing. So now if we actually now want to like extract a tar file, a compressed tar file, and this is the syntax tar. Like I said, it's still going because you want to extract. So that means you are starting with what? X. X is for extraction or unbundle. You want to extract or you want to unbundle something. With tar.gz, you've tarred and you've compressed. So we want to what? We want to first want to, decompress and also what? Unbundle or untar. So that's what we are doing here. And so unbundle, we specify minus what? Minus X. Right? And then we have to like put our what? Our Z file. Okay, that's okay. Because we we compress using what? Using gzip. So we also have to like put our Z V. So it's just the C that is changing, and then your file name, and also this. So it's only the C that is changing. Still the same syntax, just and then we have what? We have our file. So although it might not really make sense, so let me just try and delete what we have. Remove zip file 2. No, remove name.cst and sequence.cst ls. So let me now rerun the syntax. So I should now have what? Because I've deleted it, so name and this. Because initially when I deleted it, nothing was here. Now we now have it. So I think probably I should just stop here. So the remaining ones, so they are kind of like similar. It's just the command that is changing. Just the command. So you can see, so that's why I actually bundle them together. It's just the command. So if you are interested in using gzip, use gzip. So the syntax is the same. It's just the command that is changing. So I think at this point I should just, yeah, stop. Please, do you have any question? I think we are done. Next class, I will just use like 15 minutes. Do we understand what was taught today, please? 5 people or more. These people know. Right.
I don't understand what's going on, like actually. So,
Oh, I think it's a light
anyways,
issue.
after
But
I will inform them about the test today. So I'll try to upload the videos this weekend. So
the I will keep. Can you stop recording, or is there a way?